All right, everybody, we're out here, beautiful Colorado, and Megan and I are on the trail today. We've got our 94 FCJ80 Land Cruiser and our 2008 Land Cruiser, and we're having a good time when we got to a section of some moguls. This is where you get a lot of cross-axle articulation, where one wheel will spin in the rear end, one wheel will spin in the front end, and the truck won't go anywhere. So we're going to go over some tips and tricks and methods to overcome that. I hope you enjoy. Okay, folks, we're here. We're looking at our kind of stuck truck here. We're on some moguls, and things aren't going so well. Hun, go ahead and give it some gas. That's good. Go ahead and stop. Okay, as you can see, we're at a point where one tire is spinning on this side, and if we walk around, go ahead and give it some gas, hon. That's good. Okay, we can see that we're stuck. So what do we do? All right, well, there's a couple things. We could use the differential lockers, which we have, but we're not going to because this doesn't require differential lockers. So we're going to roll through what to do on this truck, which doesn't have a factory traction control system. And then we're going to take our 200 series Land Cruiser and we're going to get it stuck here too, and we're going to see what to do when we have a factory traction control system. Now we're going to use two-footed driving to get out of this. So we're going to have Megan put her left foot on the brake hard and then right foot on the gas. We're going to have her rev it up to about 2,000 RPM. And then we're going to have her slowly release the brake until she gets traction. Good job. Keep going. Keep going. Great job. Okay, you can stop. Hold on. So why does this two-footed driving thing work? Why does it seem like I get a differential locker when I apply the brakes? Well, let's take a look up here. So right here we've got a little diagram. We've got a kind of a diagram of a differential here, and then a four-wheel drive. So here's the rear differential. Here's our transfer case or our center differential. Depending on the type of vehicle, whether it's all-wheel drive or four-wheel drive or selectable four-wheel drive. And right here we have a front differential. So we kind of have to talk a little bit about how a differential works before we can get into why this works. All right, so in the video, let me find my pen here. In the video, we have our passenger front tire is spinning, and our driver rear tire is spinning. Also, they have the least amount of traction. So these are low traction. Well, that's because of the differential. The differential, without getting too much into theory, distributes power in the path of least resistance. So if I push on the gas, like in the video, the natural tendency of the differential is to transfer power to the wheels that have the least amount of traction, or the path of least resistance. Well, that's the issue, right? It's because of the differential that that's happening. Now, differentials are built so we can take turns nicely, and it allows our tires to rotate at different speeds. And that's handy for everyday driving, because otherwise you would get like a barking and a jamming, and it's really stressful on drivetrain components. So differential's there to allow the wheels to turn at different rates, and that's to relieve stress in our drivetrain. Now, why does applying the brakes help? So in the differential, our power is transmitted from our drive shaft or propeller shaft into the differential. It turns a gear, and then it turns the ring gear. And then inside here are the actual differential components. And based on which tire has the least amount of resistance, it transfers power there. So when we look back to our case out in the field, it's transmitting power down the propeller shaft going into here, into the ring gear, and it's transferring power to this wheel. And then the power's coming out of our transfer case, or in our case, I have a center differential. I won't go into the difference too much there, other than this differential acts exactly like this differential and this differential. So we transfer power down our drive shaft to our front differential, and that's transferring power to this wheel because it has the least amount of traction in the front end. Okay, so applying the brakes sort of simulates traction on our wheels that don't have any traction. So when I apply the brake here and here, basically I'm telling the differential that there's no real path of least resistance. And so just like when you're traveling straight down the interstate or down the highway, power is being applied to both wheels because there's no true path of least resistance. They both share the same amount of resistance for the most part. There are some instances, like if you have one bigger tire than the other or one deflated tire, where this may not be the case. But so I'm simulating traction on this wheel, and so the differential sort of thinks that they both have the same amount of traction. So what it allows it to do is transfer power equally to both wheels. And then this wheel that has traction will propel the vehicle forward. And the same thing goes here. So I apply the brake to both front wheels. It tells the differential there's no real path of least resistance. And we get traction and we move forward. Now this isn't nearly as good as having a differential locker, but it is a trick that works quite well. So the way that we've portrayed two-footed driving is a little incorrect. So the way that we did it is good for understanding the feel and how to work the pedals, but typically you want to already be doing this as you're coming up to an obstacle. The reason why is that little bit of momentum helps a lot as well, and you won't have to cause so much stress on the drivetrain. It's a lot easier to get through obstacles like that if you're already moving and using 2 feet. The other thing to mention there is that in the video, some careful driving, or better driving, would have allowed us to navigate the moguls easily, even without two-footed driving. But for demonstration purposes, we wanted to show what happens when you're in that situation.
All right, so Megan's got our 200 series Land Cruiser here, which has a factory traction control system called A-Track. It also has a function called crawl control. We're going to do a little video on how to use both. So we're back at the same mogul section that you saw the 80 on, and we're having a little trouble. So I'm going to let Megan give it some gas, show you that we're stuck, and then we're going to proceed to use the traction control system, and then we will use crawl control. All right. Okay. Go ahead and give it a little gas. Stop. Stop. Okay. So we're in the mogul section again. And we're stuck. We're in that cross-axle articulation. And the tires that don't have any grip are spinning. So we're going to use the traction control system to our advantage. And what I'm going to have Megan do is hold the truck at 1500 RPM and let the traction control work. So at no point during this do we want to touch the brakes, because that'll shut the traction control system off. What we're really looking for is to get enough wheel spin to allow the traction control system to function properly. Okay, hon, go ahead and bring it up to 1500 RPM. Here we go. All right, we didn't even need 1500. All right, so this time we're going to use the vehicle's crawl control. So this is sort of specific to Toyota, but it's basically a switch, puts the truck's powertrain system in autopilot, and really all you have to do is steer. All right, so we're going to go ahead and do that now. Okay, so the key here is once you let off the brake, you can't touch the brake again. Otherwise that shuts crawl control off. So what we're going to have Megan do is let off the brake. The truck might move backwards a little bit, but the crawl control system will catch it. And then we're going to let crawl control handle the moguls for us. Okay, go ahead and release the brake.
So if you remember, during two-footed driving, we're basically loading up the differential and telling it that we have traction on both sides of the differential, so there's no real path of least resistance for power to travel. In other words, power has to be divided more equally on the left and right side of our drive system. So when we talk about our traction control system, it's using those same principles, but it's doing it in a much more complicated and advanced way. So in modern vehicles, each wheel has a wheel speed sensor. Sometimes they're called vehicle speed sensors. And the computer inside the vehicle has inputs from each one of these. And so it can sense each individual wheel's wheel speed. So when one wheel starts to slip, that transmits from the wheel speed sensor to the computer, and then the vehicle uses the vehicle's ABS system to decide which brake it should lock up. So this works a little bit better than two-footed driving because you're not also adding resistance to the wheel that already has traction. So, like in our scenario, let me get my other pen here. In our scenario out in the woods, this wheel is spinning, and this wheel is spinning, and these two wheels have high traction. So in our Land Cruiser, the wheel speed sensors would transmit that there's a difference between these two wheels and these two wheels to the computer. The computer would then tell the ABS system that, hey, we need to apply the brake to this wheel and this wheel, and in doing so, that will transmit power to the wheel that has traction, and then that will allow us to move forward. So basically, if you've got an onboard traction control system, and Toyota's specific is A-Track or multi-terrain select, it's simply using the vehicle's advanced ABS system to transfer power to wheels that have traction. So, a couple words on managing your vehicle's traction control system. The number one thing you should do is open up your owner's manual and look in there and find out exactly how these things work. There's little nuances to different vehicle manufacturers and those types of things that you'll want to know. Number two, they use the vehicle's ABS system, so it kind of sounds like your ABS is working while this is happening, although it sounds a bit more aggressive. So if it sounds like your vehicle's falling apart while you're using the traction control system, it's probably normal. But definitely reading your owner's manual on how it works. Number three would be a lot of these systems change drastically when you go from high range to low range. So definitely read up on that as well. Number four, let's take a look at sort of how these things work in general. This is a very high overview. So your vehicle's computer has inputs from your accelerator or your accelerator position sensor, your wheel speed sensors, steering angle, brake pedal, all of those things. And then it outputs to the system. So it says ABS, lock this wheel and this wheel so that these two wheels can propel the vehicle forward. It might say, hey, throttle position motor, if your car's drive-by-wire, increase the throttle or decrease the throttle, those types of things, and et cetera, et cetera. There's millions of calculations going on a second, and it's telling brakes what to do and all of that. But the important thing to keep in mind is that this is just a computer. So if you're putting in lots of variation, i.e. you're either stomping on the brake or you're constantly in and out of the gas or in and out of the throttle, you're inputting variation. So therefore, the computer is going to output variation. A lot of frustration with these systems is not understanding that the inputs have to be incredibly steady in order for the outputs to be incredibly steady. So during the video, I told Megan, rev it up to 1500 RPM and hold it there. That's because one of the most sensitive inputs to this is throttle. Because if the wheels begin to go faster and faster and faster, eventually the system will not work. It will either shut off or it won't be able to apply enough brake pressure to do any good. So the idea here is start off at a fairly low RPM, maybe 1000 RPM in your truck, 800 RPM, something like that, and hold it there. And then gently work your way up until you start to sense some wheel spin. Once that wheel spin happens, that's when the traction control system can start working, because it needs to be able to tell that which wheels are slipping. So, don't start out at 3000 RPM and don't start out at idle. Give it just a little bit of gas and let the system work. And that's, in a nutshell, a high overview of how that system works. Thanks everyone for listening to our little spiel here on some driving techniques. I hope you learned something about two-footed driving and maybe your traction control system. If you like videos like this, please click subscribe down below, and we'll keep turning videos out. Thanks again.